So let's start the today session. So yesterday I completed the sliding window or two pointer approach, and we have left only one problem, that this problem, minimum window subsequence, right? And after solving this, I have decided to solve the a string problem, right? Let's check why is this slow down that much. Okay, this is the right thing. What we have to do now? First, we have to find the this window. So let me sign in first with the Google. Okay. Now let me show you my first. Let me show you my GFG profile. I haven't seen. So this is my GFG profile, and my coding score is like this much problem I solved. Coding score is, and institution rank is 24, right? This is my coding score. So just leave it. So now let's see the problem. So we have given to a string s1 and s2, like s1, s2. Now you have to find the smallest substring in s1. That okay, smallest substring s1, such that the s2 appear as the subsequence within that substring. Okay, that means we have to search for the all the character here, right? E K F R G. The character within the substring, the character S2 must appear in same sequence within the substring of S. Okay, if there are multiple valid string, okay, return the minimum length and return same length, same minimum length. Return the first appear in the S1. If there are no such string, return the empty both the string. What we can do here, like don't think we can able to use like if S R, can we use like not a G, so increase, yeah, increase, it's K, not a K, and it's I, okay, it's I, so I here, it's not a, so we increase I, it's increase, let's just start from here, next, E, K, like starting from the second index, it will take second index here, we make like we make EKSRG to find, let's just wait for a second. Sorry for the inconvenience. So let's see if we take the S1 and R1 is equal to 0. So we have to let's see the concept like so if we have the CFG Greeks 4 Greeks and the S2 S2 is like a GKSRG, right? If you take a pointer here, now that's it. This is not equal. It reached starting from here. We find this much, this much, this much, this much, this much, this much, this much. So we go like each character from here to here. We find EKS for R's. This much solution we can find like SRG, SRG. Okay. So now we have this much. Now we have to shrink the window. Not a this. Now let's see. How can we find that like lining window if you use? I don't think so. I1, I1, I2. This for this, this for this, SRG. SRG. Mm, we have to travel like here to here. This much. Now we have to spread. ये पूरा आया starting the thinking, right? Still the store, right? So we have to shrink like possible. Okay. So in this we have proper. So as you see, this is the sliding window problem. Let's see how this can be solved. Like you are given to a string, right? As G. So we have to, so it's like a source of SDST to okay. So it's literally like 20. So 10 into 20, we can go like a, yeah, we can go n into m time complexity, right? Because the S2 length is 50. So we can go. So, so what can we do right here? Give me 2 minutes. I will be back. So let's let's see the mind is a problem. Sorry, a string problem. I can I'll solve this problem at last. So this is the for the last. Now let's start the session of a string. Okay. So so let's start from the easy and basic string problem like this. So in this question, what this say? My internet is a bit slow. Sorry for the inconvenience. Okay, 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 okay. Why are you doing this? Oh, okay, you need to log in. To log in. This is a bit slow. So now let's see. We have the question. Remove the outermost parenthesis. Okay. So a valid parenthesis string is either the empty. Okay. And there is closing bracket and open bracket. Okay. Or a plus b. Character a plus b. S1 is either it. Okay. So now here is the valid parenthesis. Okay. C for represent the string count. That means this is valid. So valid string is primitive is if it is non-empty, they are non-existent. So given a string, given a valid parenthesis string as considered the primitive decomposition. So you have to return as after removing the outer parenthesis of every primitive string decomposition. Okay. So we have to validate the string, right? So here we can use the stack like this, okay, this, okay. I got this, so I got take out this pull up. Now again this, so I got again got this, um, this. So this remove this. Now this again this, okay. So remove return as removing the outermost parenthesis of every primitive string in the string decomposition. Okay, here we have to remove this much and this much. Okay, fine. So right here one right and the one now it's become one. Now it's become zero. Now it's become zero. Like here, it's a one. Okay, it's a one. Then it's a two. Now it's a one. That means this and this much is primitive. Okay. Now again, it's a two. Okay. It's a two. Like we can use here the stack of the problem. Like so, very parenthesis. We have to remove the outer value, right, of every primitive. So here, if we remove here, what the question suggests, like this is the one size, so we have to remove the outer primitive, like we have to remove this. Sorry, this we have to remove this and this. Again, it's another primitive string, so we have to remove this and this. So final answer contain like this much and this much, right? And in the second case, we have a primitive string like this, so we have to remove outer outer parenthesis. So the final content like this much. Again, we have primitive here. Again, we have primitive, I think, here, right? So we get here from two, and one from here, and this much here, 2 0 and 2 1. Yes, and here nothing inside, so it's empty. This is the, so we have to remove only the, I think we have to remove only the outermost outermost parenthesis of every primitive string, right? So what we can do, like we can use the, I think, numbering system, like it's one, then it's again it's two, then again it's become one. Let's see. Let's see after trying that run what the result could be. If if I use the stack like this, become this become this. Now we get the value. So if we're removing, after removing this, we get something like okay. So this okay. So this become this. Now again this become this. Now this. If if we remove and if we don't do nothing, so we can't add this. Now empty. So let's see. Let's do that just like this. What I am trying to say here, like we can use the stack here, right? As dot size, like we can use the character st. Now let's fulfill like this much. So if the if the like si is equal to this, so st dot push, see, st dot push is equal to, right, sorry, si, right? Else else if st dot not empty, not empty, and st dot top is equal to not equal to si, then we have to impede the, like we have to ch like st dot top and st dot pop, right? St dot pop. Now, if st dot it become empty, so we have to just continue it. Else we have to add in a string like else add resultant a string plus equal to we have to add character plus si. Okay. Now a string a string resultant. Now let's see this what this return resultant. It's a easy problem. Let's say pass the test cases or the fail the test cases. The internet is bit slow. It's consuming mind like wrong answer. Let's see why are they giving the wrong answer. Oh, Q. Why Q? st dot top not equal to st dot I. St dot I. Okay. Just put here the character right. Just put here I. I symbolize. Just put here. Let me stop it. So we have to take like S S. So just like this. And if else is provided like st. So not character like it's equal to this and si should be this much I think. Right. So let's see this what this result get return. Think we can use like the result then. If it is yes, we can add it to this result and push the value. Okay. Else if it is empty, we have to stop. So let's see why this returning that returning this much. So like if the si let me say Why to return the QQQ? Some kind of joke. I okay. First add this. First add this and second add this. Okay. Let's see. Now I think it should be add right value, right? Let's say in the internet it almost removed, right? Internet is like a, sorry, I think something is going with the my internet. Connect with the let me connect let me connect disconnected. Yeah, let's say bad. Oh, I think there is error in my internet. Yeah, this is right. So I think then so let's see this problem is either available in GFG or not. Let's say solve in another platform. Take to forward tutorials outer practice. Let's say yeah, it is present on this. So let's solve it into GFG. So what I'm going to do first we have to take the size of two and the state and a state. So just we have to remove the outermost element, right? So right we can use two methods. First I if si is equal to outer, then just we have to push I, else if st, I think it is not entity, right? It might be possible it's not full entity because all the character is valid, right? It's a valid character, so it not should be the entity. So else we have to just check like if character sh st dot top, right? St dot top and st dot pop. If st dot if it become empty after popping, so we have to just not to do anything else, just continue, else add ch and shi, okay, and we have to return the result, right? So let's, sorry, let's see, this is going to pass, okay, not this question mark added, okay, sorry, yeah, let's try to submit it, or this is the wrong answer where, for this input, okay, your code output is itna, my output is itna, so we have to remove this much, this, and so this, if we take this, 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 so this first add up, okay, this much first add up, um, first add up, then again this much add up, okay, the logic is right here, but what we have add the valid, that means we have removed the character, but we are not added it in right order, right? We redefine the order, so we just have to do like, if st is not empty, then we have to add si and st dot push I, okay, else st dot pop, right? We have to pop, and if after the popping it is not empty, right? So we, then we have to search for add this much, or you can say as this. So this I think this is going to pass, I think, yeah, this is good. So in the first solution, what I am trying to do, right, I am just removing the outermost parenthesis, right? Just I have like in this let me show you with this case, yeah, let's take this case, sorry, in my solution, in this, so let's directly copy and try to submit it. Let's copy here and take a custom input, just remove this. So what I'm trying to do, like here, see, I'm trying to do like we inserting the element one by one in a stack. If we can't find the closing window, right, a closing parenthesis, so I store this much in a stack. Now we find the closing window, so I take this into the string, then again take this, sorry, this much, this and this on a string, right? Again take this and this, so I have removed this and this, okay. But what I'm not doing, like we are not preserving the order which is described here, we redefine the order, that's why it's giving the wrong answer, right? So like my output like this, and expected is this, like that's why I in the second code I what I'm do, like if the if the array is not empty, so it's completely that this is not, the parenthesis is not going to valid, right? So that's why I add up this much. Now, so this is the solution. Now let's check another solution, another code. Like I think it code is passing. So reverse the string. Sorry, so this person solved. Now let's reverse the string. Reverse the word string. Reverse the word in a string of around three. Okay, what is this mean? So given the string of s, reverse the string without reversing its individual word. Okay, the word are separated by dots. I like this program very much. So I like this. Okay, just we have to take a vector string and we have to add on that, and we have to, then okay, that's my right. Okay, so this may contain leading or trailing dots or multiple dots between two words. Return the string should be have single repeated. Okay, single dot. So I, you find the dot. So continue I dot. Now from the dot, if it dots, so remove string is empty. If it dot, continue. If the string is empty and it's dot, continue. Right. Okay. Huh? Yeah. Yeah. So now let's say. If the we take a string vector and try to put all in like one dot like dot, and after reversing we add its element like this. But I don't think that, yeah, we can do it like right. So let's see how can we take. First we have to take like a vector, a string, one temp. Now we have a string, sorry, vector temp result 10 and take a temp. Now we have to take 4 int or take like a auto x s. Now if the x is equal to dot and sorry, as dot is empty, then we have to just continue. Okay. Now if x is equal to right, else if x is equal to continue, and temp is not empty. Temp is not empty. So what we have to do? We have to just resultant dot push temp plus equal to dot, sorry, x, and resultant dot push back temp, right. And now we have to empty that, empty, right. So just like that, else add temp plus equal to x. Now reverse the reverse that sorry reverse the result dot begin and result dot end. Now take the final answer and auto x result answer plus x and return answer. Let's see this is right or wrong. Or sometimes I like what is this? I like your output is very program. I okay. Reverse. I am reversing that like so. Let me see first what is the output of result. See out that's okay. Just we have to check what is the output of result. Okay. So in the final output, if m if m is not empty, then we have to result plus sorry result dot push back m. Now let's see. I like this program very much. Okay, I like this program very much. Okay, so this comment out. Now let's see. Mm, very much. Okay. Expected. What are you printing right now? Returning your output should be result output. I like this program very much. If we reverse the element, so my uh, expected output much dot vary like this like this very much. What is the difference? Why I'm getting that much? Yeah, but I'm getting right now much very program like this. So where is the dot? Why can't you find the dot? Let me record. Yeah, think I program. What? Yeah. Yeah. So why this? Can I think where is my error? Like I like program this much. I don't think here. If the not so I and we get the dot I dot. So if I dot it's empty not empty. So else it should be and not empty. So we have to add like x. We add the I like. Now it's become a now we move that like like add like and we get dot again dot and what just we have to add this. So why are still getting the error? Don't understand? Remove. reversing the area like this temporary not take 4 out of 10 plus T. So like that all set if we remove this and add this much only. So what I like just add here temp plus equal to just add two string one, right? Just add one. What I'm trying to do. I like okay. So and for here if x equal to 1, then add result or dot else for answer else we have written else first x, right? So let's see this going to help us or not to mean that x should be greater than lower answer x character. I don't think so. Okay. Now I get it. Now I get it, get it, get it. I get it. So the problem, what problem? Now I get it. Result plus x, right? So just we have to remove this much problem. Now just result dot to the back. Just add this. Result dot x. Result dot x become answer dot x. I like very much. I like very much. So first I'm going to try custom output or that. Okay. So what is this problem? For input the correct output like not or not like this problem not I like okay your output is much I like why we are adding much here like much. Okay. This much. Okay. So just do here one thing like what just one thing here while while while- just do one thing if result dot if result dot back is equal to then result dot pop back, right? I think this much can pass the with the custom output add here. So just add a symbol here and symbol here. Let's see. And this also this pass. Okay. It's going to pass out the yeah. This was solved the problem. So this much. So this is the solution. It's a very easy solution. Like if we find the dot, if the find a dot or the array and the temporary is negatives, that means we not add any character on it. So we have just to continue. Or if it find the dot or that some character is available on it, so we have to add into the we have to push into the vector, right? And that's it. And the last, this is checking for the last condition, and this is checking for if we find the last is dot, so we have to remove that dot, right? Now we are reversing and adding into the a string and returning the answer. So now let's, the largest odd number in the string, the largest, find the largest odd number in the string. So it's a 501. Okay, let's find the largest odd number here. Okay, we have that. Okay, so given the string of representing large integer, return the largest valid odd integer such that the substring, such that is the substring of a given string. Okay, okay. Let's see. So we have to find the largest odd number, right? And that that largest odd number should be the substring of s. So first approach is like if the so we have like 5 5 0. It's if it is odd, like we have to from the last, right? 405, no, 404. If it's 4, we can't take. If it is 0, we can't take. If it is odd, so we take. We can take that one. From there, we have to do like odd. So we can travel from the uh, you about the odd number. You can say that like if the unit distance, sorry, if the unit digit is odd, so that's that means a string should be odd, right? So what we can do here, like we have to travel from the back. Okay, x x just first reverse, sorry, reverse the s dot begin and s dot end, right? We have to travel from the back. So if the x minus 0, if it if the number is odd, right, we have to just add from there to all element to the right. So just we have to find the index row, right? So index idx is equal to -1. Just we have to travel from the back. No, why travel from the back? Mm, yeah, why we have to travel from the back? Sorry. So why we are reversing it? Let's check. Okay, if si minus 0 is odd, so index, sorry, I and dx should be I, right? Now just we have to add from 0 to I and x, right? And I plus plus, and the result should be x plus I. And if if I and dx, sorry, I and x is equal to -1, then we have to return the empty string, right? This much the solution, and return the, sorry, we have to just not a reverse, return the result, return the result, this much. What is the n is not defined, so we have to take n as dot size. So this much, let's see, this passes all the test cases of failing. Okay, we are reversing. If I and x dx, okay, we can't just break now, break, just break. We have find to the targets now, just break the earth. This much, the past the solution test cases. So this is the VGS problem. Now let's longest common prefix. Uh, okay, so I think the lead code is back now. Yeah, I think so. So let's, I think the lead code is back now, right? So let's put it, let's see this solution all run on the test lead code problem. So first we have here s, yeah, lead code is back. Find the largest, we have to, okay, yeah, this must solve. I think this is size blue is just fine. So this is like a spaces. So this much problem here. In this problem the version is just like that. There is in the GFG platform the dot is present, but in the lead code, the space is present. Simple, same question. So I don't waste time here. Let's solve this problem. Write a function to find the longest common prefix string amongst an array of a string. If there are no common prefix, return the empty substring, right? So we have flower, flow, flight. So longest common string is like a flower. So, okay. So if we take the full, we can do here like sorting with this according to size. So we get like a flow, flight, flower. Now this we have to take all the size. So we can't find all the size here. We have to just move back to the flower, right? In the all, there's no common prefix flow. Now we have to pick the flow, right? So flow. The answer is flow. So we can sort according to the size, car, dog, and the recruit. So we take the full length and str 100. Any other approach like just just sort the strs begin and strs in helper function. Sorry, it's an auto A, auto B. Now we have to remove like just we have to remove that A dot size should be less B dot size. This much solved. Now int s is equal to strs dot size. So if the n is equal to 1, so we have to return the whole strs 0. Now let's move the problem solving of n and and now let's match up the substring. We take the flow flow like as you know a string valid we have strs 0, right? Now we have to check. Now now valid function is helper stri valid, right? So if the valid is equal to strs like helper function, what to do helper function. So we have flows and the flowers. Now we are matching this much our character remove flow. If we match flow flows return. Now flows and the flight matching flow flight not matching remove. So fl valid we get fl. Now dog It's valid should be. So now let's see like valid should be empty. Empty. Valid should be empty. Here we can choose if the I is equal to 1. So we can here in the place of I. mm, if valid is empty, so just we have to set up like we have to we have to give strs strs I minus 1, right? And if valid is still empty, then we have to return the valid, else return the valid. Okay, now let's build the helper function. Just build here auto helper. We have to add so now let's see if we use the lambda function, right? So it's a string, right? So a string, like we have to add a string and the valid just like this. Now take sorry, just like this. Add this. Now a string resultant is equal to empty. Now just we have to like so just what we can do then take int I, int j, int like value dot size, and int plus plus if the value dot I is equal to s dot I, so we have to add into resultant valid I, else we have to just break. Sorry. Now return the resultant, right? Let's see this pass the test cases of the fail or something. It's not happening. This is flow. Let's say I just give the flow. Let's first see that STRS, right? Let's see the first with what we find in STRS. Flower flows like okay, this much. So if the a string is empty, yeah, a string is empty. So we call the str and flows, right? So if the strs flows is flows, right? Now again, okay, else, not we are calling else. Valid is equal to helper, str, strs, I, and the valid. We are not calling this. That's what is giving the wrong answer. Let's see this pass the test cases or the not. Yeah, this much. So what I do here? Just I sort the vector string. That means sort the vector according to the their sizes. That means the minimum size should be in the first place. So and comparing with the that should be that with the prefix should be equal to the previous prefix. So now so let's see what is the solution other explained here. Let's see this much. So time complexity. Okay. I think this much right. So we are strings s length while s dot length to str. Okay. So this much also good. Also good. Not I don't think like so. What here they done is like they done here like uh, okay. They sorting it. Okay, sort it. Now we are using like ST Rhode Island. Okay, and comparing all the characters. Only we are comparing the first and last. Let's see, first and last, and returning the answer. This is good. Yeah. Name of it. So this now let's move the next question. Let's move the next question. Like isomorphic substring given to a string st and t s and t determine if they are isomorphic. Okay, what is isomorphic? So two strings s and t are called isomorphic if the character in s can be replaced to get t. Okay, character, that means if the character in s can be replaced to get s. Okay, all the occurrence of character must be replaced with the another character while preserving the order of the character. Okay, so no two characters map the same character. The character may map to itself, like egg. Okay, so here CG add. Okay, flip P1 2. So AD. He become A. Now she become D. Now C. So here C. Okay. So take the map character into character. Now let's store like E become A. That move to G. Now store the G and checking for D. So it's not so D become G. Now move to G. It's fine that it's already present. So let's see Ti should be equal to G map TI. Right. Yeah, it is present. So let's move the next character. Okay. So this is true. Now let's F11 P23. So, so now let's move make FB1. Now make 1, 2. Now so not so false. Now let's check the paper and the title. P is equal to T, A is equal to I. Okay. P is equal to T. Yeah, that is fine. P is equal to L. That is fine. And R is equal to E. That's not satisfying because E is equal to L. So R is equal to E. It can be. It's a true. So let's see. We can map this out. We can map. We can map this. Let's make a map of character 1, character 2. It's a mapping. So mapping. Now just we have to take n is equal to as dot size, right. Let's any test cases you want to check, you can check always. It's now let's move in 0 and m in plus plus if mapping dot mapping dot mapping dot count find uh, si, then we have to like if 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 mapping dot si should be greater than t dot I, right. Then we have to just not we have to just okay else return 0, return false, right. Same approach. Now just we have to add else mapping dot si is equal to ti. Let's return true answer. Let's see. This is the fastest test case, but I think this failed the. I think, yeah. What I'm trying to do, like I'm mapping only the S1 character, but what about the T1? Like this BADC and BABA, like this much this great. So B is great, A is equal to A, so this A is equal to A is great, and then B, okay. So just we have to take like S is equal to T. So just no need to map, no need to map, right? So we need to map. So BB now B is equal to B, B is equal to B, and C is equal to A. So we have to return, right? So BBAA map stick, okay. As management and C corporate income, okay, C calculate expected false. Why? Why false? Like P should be A, okay, and A should be A. Sorry, B should be B, A should be A. Now E should be B. Mapping the D to B. Okay. Okay. Got it. Got it. Now, please put me check both sides now. Check both sides. Check both sides. Else if nothing dot count AI. Not check like both sides from nothing AI AI that side. We have to just to map now. Yeah, we have to just map things. Think AI को भी तो ऐसा ही कर रहा है ना. Okay. Sorry, don't mention it. What we are losing here, like we are so so what we going to do here? Like two character S and T determine is the S. So like if we mapping E with S, so we mapped out paper P to T, A to I, and T to P both and both P should be Q should be yeah R to E to T. We map E to C. Now we map L to E. Both are interrelated. Right? Two characters may not be two character may not be mapped to same character. Okay, so we are mapped here like P mapped T. Okay, A mapped I. Okay, and E mapped L. Okay, and R mapped E. Okay, this much is good. This much is good. So it's a true. Now let's move the we got the wrong answer A B D C and B A. So this much. B is equal to B, A is equal to A, right? And B is equal to B. This much I think this is the wrong one. So do you think this is the wrong? Okay, let's see. If it is already present, D is not present now. We can map the D with a B. Yeah. Now C with A. We map C with A. So we can map the C. So it's become like a B is map B and A is mapped is equal to A and D is mapped to B and C is mapped to A. So it's a Baba. So it's a true. Why this gives the false? Let's understand the question. I may not be understand only the question. So the all the occurrence. So given the string of S and T determined is the assumption all the occurrence, right? All the occurrence of the character must be replaced with the another character while the preserving the order of the characters, right? So this much like a so we are mapping like if the character is already mapped, we have checked like from the T1. So just use the two-side mapping because isomorphic says sorry, you need to take the mode cipher things like like check the character A S1 character B is equal to T1. So if the mapping mapping one count if the mapping one count Si now if the mapping Si is not greater not equal to B, then we have to return the false. Else if right else we have to just mapping Si is equal to Ti, right? Now next the problem next it is like if the mapping 2 dot count Ti, so we have to check if the mapping 2 dot Ti is not equal to A, so we have to return the false. Else, as the condition like a mapping 2 and the Ti is equal to A. This much the solution. I think this should pass all the test cases. What is the mapping Si? Si here, it is 1. So let's see, is this a good or a bad? Is this running or not? So this passed the test cases with the 100% solution. Let me see then my solution which I submitted on December. Let's see what I'm doing. Yeah, same concept I used because it's need the both side mapping. Now let's move the next question. Rotate the string and check to a string or amalgam of each other or not. Rotate the string. So I think this is the very easy solution. Given to a string as goal to a string. You have given that to a string s and goal if true is return some number of shifts. Okay, we have to shift. How much we can shift? Like A, B, C, D, E. Next switch. Next next rotator should be some number of shift. Leftmost. That means the next C, A, E, B. So it's more like a leftmost switch. So we can use that helper function like A B, C, D, E. So we use like switching, make the resultant and I is equal to I plus this should be goes to there 4 in 0 in and minus 1 below 0 plus 1 2 3 4 5 5 5 minus 1 4 4 so it's the 4 4 नाम लिया so 1 plus 4 1 plus 5 minus 1 it's increasing 5 minus 1 so it's 1 so it's become it become it's become at a position of 0 right it's, it should be 0 so 1 plus 5 I plus 1 minus I 1 plus 1 plus minus 1 leftmost 1 2 3 4 5 so we increasing leftmost right part 2 3 4 5 1 0 1 2 3 4 4 2 3 4 5 1 so now check now let's see after it say bola 1 plus 1 that means 0 plus 1 2 1 plus 5 2 plus 1 3 that means 3 plus 1 2 1 plus 2 3 3 plus 2 4 no 3 plus 4 3 0 0 1 plus 5 each element have to check like now what can do just we have to just use by I I dot I dot size if if s is equal to goal return true else return false now check s is equal to helper s now what is helper in 0 what is helper auto helper auto helper. Up. Now let's say result for min 0 min s dot size s dot plus 1 and s dot size return result. Why? Why that? What the fuck? Let me see myself. Just once? I don't think just once. Okay. B C B C D A. Next call C D E A C. Sorry. B. This much. Now helper checking return 0. Just once. I don't agree with this. I don't see that just once. Let's take a string here. Valid. Valid. Let's say valid. String s is equal to valid. Sorry. Valid is equal to s. Yes. We call here. Now let's see why this not running properly. Why this give the wrong answer. I don't think so. So this much. This is the problem. Not quite right. Like little bit problem right now. And as your size, we have to do. Just we have to do like let's see this pass the test cases or not. Yes. So let's see my previous solution. My previous solution is also very easy. Like I used LPS, longest common prefix, longest LPS, longest prefix suffix. I used. I made a LPS here. It's a LPS. I cannot. Now let's see. And the medium problem should be art. This should I can I can solve this much today. So this today I'm going to solve. First, let's see that's the problem. Let's solve this problem first. Okay. So what this problem said that sort character by frequency. You are given the a string sort in decreasing order based on the frequency of the character. The frequency of a character is the number of times it's appear in the string. Return the sorted string. If there are multiple answers, return any of them. Okay. So what we have to do? Just we have to do like character by sorting. Sorting the frequency sorting. So we take the vector, pair vector, and the store the character with their frequency and the sort accordingly to the frequency wise. Right? Like E appeared twice, so it's greater, then it's come down before the E and R. So like both are characters, so both are characters. So C and correct. Same character must be together. That's it. That's it. Okay. What's what is the problem I think here? Tell me, what's the problem? Okay. One thing I have problem like and this problem like this sort the character. There is not a single character. So if the two value is greater now, so we have to take the size element, right? So let's put it like let's take a map character in and frequency. Let's take a pair int and character and p. Now for photo as now frequency x plus. Now we have to move this. Now we have to move photo x frequency p dot push back frequency dot x. Sorry, x dot second and x dot first. Now just we have to sort p dot begin and p dot end, right, end, and just we have to sort like photo a, photo b, like if a dot first is equal to b dot first, return a dot second b dot second, right? Else return a dot first greater should be b dot first, right? This is my solution. Now take the resultant array. Now auto x. Uh, Here we have just leave it. Ch, no, it's frequency, character, and p. Now resultant plus add What? Just we have to add a while frequency minus minus. The result can add ch. Result result. Yeah. This pass the test cases. Let's see. This passes all the test cases or not. Yeah. This must passes all the test cases. That's the final version of my life. This is the question. So I solved it on the now let's see today's let's see the problem of the day today. Find the prefix commons of array of the two right here. Find the prefix common array of the two array. Okay. Given prefix common array like A and B. So given the common prefix like of A and B just array of C such that Ci is equal to the count of the number that is present at 8 or before the index I in both A and B. Okay, return the prefix common of A and B. Okay, okay. I understand. Like 0, we have to nothing, and the 1 we have to 2, and no common element at 1, 1 and 3 both in common A and B. Okay, yeah. So two element. C 1, 2, 3. Like 1, 3, 4. 3, 1, 2, 4. Like 0, 2, 0, 1. Now 1. Present in here and this is present in here. Yes. So it's become 2. 2 now. Now let's see. From here. This present here. Yes. This present here. This um, not, not equal to so it's 3 equal to 63 not 4 4 64. Now let's see. Let's make the character. So it's say that the exactly once, only contain exactly once the sequence of it. You are given the permutation of A, B. Okay, so permutation is even. Just we have to find the A, B both in common A, B. So A, B 3. One character has 2, 3, 1. 3, 2, 1, 0, 0, right? Now we have to solve with this so, yes, take देखिए होगा yeah, just this is so much easy. What I am going to take a map. 1, 2, and 1 4. So let's check for the 2. There is nothing, so 2. And now next one, 1 and 3%. So let's 1 3. We have to check for the 3. It's present. Yes, it's present. 2. It's a 1. It's present. Yes, it's present. It's present. Both are present. Right. Up to. So 1 3%. Now it's at 2. It is present. Right. So the equal to the present. Okay. Present. That equal to the count of number that are the present 8 or before the index of I. Okay. So we have to add like this. So 1 to find it this. So this much. So what we have to do, like if we take a map from the beginning at the 0 index, like 1 3 2 4 3 1 2 4. So it's at the starting index. There is nothing common in both the elements. So we have to put the 0 at the next. So map contain now 1 and 3. So we are here and here. That's a common in both array, right? So given the Si is equal to the count of the number that is present 8 and 4 in this in both the array, common array. I have to count the number of array. So 1 3. So it's like 1 and 3. So it's present. Yeah, it's present. So 1 1. Now it's present 2. Now let's put the 1 3 2. So 2. Now let's see. So 1 2 3 is common here. The both are prefix, like 1 2 3. So it's a common like over here. It's a common. So it's the 3. Now it's a common. So it's 4, right? Now in the second test case, 2 3 1 and 3 2 1. So 0. Now we have 2 3 and we have here. So 3 is present, but 1 is not present. So we can count the 3. Common in both. Okay. So this much, I think map 1 and 1, 1 3 and 2, 1 3. Right. So 2 2. I think that this present is both and 1 and 2. So it's a 1. This present both in and 1 and 2. So both. I put and 2 and 2. So it's a 2. Now let's see. It's present both 1 2 and 1 2. Yes, this present in both and 2 and 2. So we have put 3. Now let's put, yeah, this. Now let's see for these test cases 2 3 1 and 3 1 2. Let's map 1 and map 2. Right. If not present, so it's a 0. Now let's see. Put here map 1 and map 3. Right. Now let's put here 3 and 1. Now check. This is present here but not find. So yeah, this able to find here. So it's a common. So it's not 1. Now let's again search for this. This is present here but not. So its value is 1, not increased. Now, now, now check for like this. So this much in the okay. Now go for here. It's 1 and go for 3. Now check. This is present to M1. Of course, this present M1. This present M2. Yeah, this is present M2. And is this present M3? Yeah, this is present. So it's a common. So it's become 1 plus 2. So it's become 3. Right? 0, 1, 3. Yeah. So we have to use map 1, map 2. M1, M2. Now let's see. Let's check for 0 size. Let's see. Like we have to put first M2 dot AI plus plus M2 dot BI plus plus. Now we have to check what to do. If M2 dot count of AI, sorry, AI and M2 and M1 dot count of BI, BI. So what both are common in, so we have to just not a DP thing, not an DP. We can use like I is equal to I minus 1 plus 2, right? Else if else if else if the M1 got count, so I minus 1 plus yeah, the 0. If M2 find M1 I, right? So we have to just add the result I plus 1 equal to result I minus plus 1. Else if M1 M2 dot count like B1 BI, so we have to result plus sorry result plus result I minus plus 1, right? We have to return the result. Let's see. And if the I is equal to 0, put the else here. Sorry, put the else here. Then we have to result I is equal to 0. So let's vector int result a dot size. Let's see this pass the test cases or not. Is the phase where I okay. So this increases the size y. So we are saying that we have to increase 1 by 1, not a 2. If we increase the 1, if we find like this, okay, if we find both common elements and Do not find anything. Okay, 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 okay. So you put 1 3 1 4. Okay, 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 okay. This is going to this. If the AI, sorry, AI AI is not equal to PI, right? Else we have to I plus is equal to result I minus 1 plus 1. I think this should give the right answer. Yes, let's submit. I don't think this passes all the test cases. Let's see. Yeah. So it's failed for the test case 1. 1 is equal to 0. We have to 0. Can I check for the okay? So I can remove this much, right? And I can just put simply like if n is equal to sorry a dot size is equal to 1, then uh, what we have to return, right? Yeah, return a dot 0 is equal to b dot 0 if it okay, 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 all right. So return 0 else 0. Can't we use right hand operator? If it is 0, we have to return we have to return the back result 0. Not return the result. Return the result which called let me see. If the A is equal to B of 0, so we have to return like result. No, no, no. The result 0 should be 1 and return result. Else return result. I think this so far the test case. Internet connection will be poor. Else what is the problem? Input count. Else if and input count. Okay, okay. Yeah. So with this test case, show me the result. Output 0. Screen one to three four. A screen is low. Screen not visible. Sorry, I can't. No. Let's fail. Why fail? Oh, okay. So I think we are good with this. We are failing, right? Now let's say 10. So if we remove the right 0, okay. So just remove this. If so, both is fine, right? We are fine. We are fine. Just just use the approach, like just use let's approach like put the result 10, result 0 is equal to what? A dot 0, A dot 0 is equal to B dot 0, okay, is equal to 1 else 0. Just put the solution here. Let's see if all the test cases or not. Black page? I don't think so. This is the today's last question. Connect is a bit slow. Why? I think A and B is equal to. Now why will it okay, let's just remove this problem. Just use from here, right? Use this this here 0 here 0. Let's see this pass the test cases or not. So test case like 1 1 1. So 1 we passed. Now 1 2 3 1 3 2. So it's the 1. It's common to both. Now we 1 3 and 1 3. Right. So let's not then. So if we can't find any else result should be I is equal to result of I minus 1, right? This should be present. This should be present, I think so. No, I think just one solution, right? So 1 2 0 2 3. So let's find. Yeah, fine. I can find both common. So it's a 1. Now let's find 3. Not common. So it's a 1. Only 1. Right. Uh, Now let's move the next problem. 3 and 4. Now let's move the 4. Yeah, it's a problem. Then it's a 2. So here we have to add now plus 1 plus 1 plus 1. Just like this now. We have to just like add this. Let's see this pass the test cases or not. Yeah. So the question is a bit tougher because I made this much wrong answer. But this is not a hard problem. Just you have to take observation how to solve this problem. Now let's remove this. Let's what is this? Yeah. To given a string s and t, return the true if the s is amalgam of two otherwise false. What is amalgam? Oh, anagram. Anagram. What is the difference? Sorry. HTML also character. What is anagram? What is anagram? Anagram. Yeah. Okay. So if all the character here present here, we can just all frequency difference. Just we have to take the frequency. Just compare the take the storage and should be should be equal to use the map. Just like sorting. Yeah. Sort the it is not character then sort sort as dot begin as dot as dot end sort t dot begin and t dot end, right? So this now I don't think the length should be greater like if the s dot I is not equal to t dot t dot psi, just return the false statement. Now we have to put just if s dot I is not equal to t dot I, return return false, else return true. So let's try to submit. Yeah, this is pass. So that's it. I solved the eighth problem here and one problem from here. And also I solved the today POTT